Given a table of properties for different molecules, and using your knowledge of intermolecular forces, why does H2O have a higher boiling point than hydrogen fluoride? Well, we can see that the molar masses are similar, and so are the dipole moments. And if we draw the molecules, we can see that both types of molecules are going to form hydrogen bonds, so we can't really say that the difference in boiling point is due to the dipole-dipole interaction. But what we can observe is that the water molecule has 3 atoms in which it can form hydrogen bonds, whereas the hydrogen fluoride molecule can form hydrogen bonds at 2 points. So given that 3 intermolecular forces have to be overcome because H2O is going to be bonded to 3 other molecules, we can say that this is the reason why the boiling point of water is higher. Which intermolecular force causes acetic acid to have a higher vapor pressure than propanoic acid? So here we can see that the vapor pressure of acetic acid is higher, whereas both acids have similar dipole moments. And given that the molar mass of propanoic acid is greater than that of acetic acid, then we can attribute the higher vapor pressure due to London dispersion forces. And for clarity, we can draw these molecules, so just following CH3, and the carbons are bonded to each other. Then we have an oxygen double bond with another oxygen bonded to a hydrogen. And for propanoic acid, again we draw the carbons bonded to each other. And then we have H3 around one carbon, and then H2 around another, and then we have 2 oxygens and a hydrogen. So here we can see both acids can form hydrogen bonds with their molecules, and the propanoic acid molecule is larger. So the London dispersion forces are going to make it more polarizable. Let's rank hydrogen cyanide, H2O, and nitrogen gas in order of increasing vapor pressure. Well, vapor pressure applies to liquids, so we can ignore nitrogen gas. And if we draw these molecules, so hydrogen cyanide and H2O, well, H2O can form hydrogen bonds between its molecules, whereas hydrogen cyanide can form dipole-dipole interactions between its molecules, because you have a polar covalent carbon-nitrogen bond. And hydrogen bonding is stronger than normal dipole-dipole interactions, so therefore the vapor pressure of H2O is less than the vapor pressure of hydrogen cyanide. Which interaction is dominant between H2O and dissociated ions in an aqueous solution? Well, for example, when sodium chloride dissolves in water, you get sodium and chlorine ions surrounded by water molecules. So the negative dipole around oxygen gets attracted to the sodium, so you'll have something like this. And you'll have a similar arrangement for chlorine, except the positive dipoles around hydrogen will be facing the chlorine, and so on. So therefore the interactions between the ions and the water molecules are going to be ion-dipole interactions. If magnesium or calcium ions are placed in an aqueous solution which has a stronger interaction with water molecules, and why? Well, the positively charged ions are going to be attracted to the negative dipoles around oxygen in the water molecules. And given that the atomic radius increases as we move down the periodic table, well, the nucleus of magnesium is going to be less shielded, and it's going to be closer to the oxygen dipole. And because these cations have the same charge, then you can have a stronger ion-dipole interaction between the magnesium cations and the water molecules.